dick from the internet. Now do it right. That'd be great.
Welcome to DLab Electronics. And in this video, I'm going to show you an easy way to update those old filter capacitors in your Dynaco PAS tube type preamp. As you know, those old original parts are hard to find, and if you do, they're probably as leaky as the ones you got in it now. So why not upgrade it? And you can do that using this SDS Audio Labs Capacitor replacement board. The installation is very simple, and when you get done, you'll have a top performing preamp. So here we go. So here she is, the Dynaco PAS tube type preamplifier. Front panel sweep. See, she looks perfect. Not much wear and tear to the lettering. Flip it around here, take a look at the back. There's the old Dynaco stereophonic preamplifier decal. RCA inputs. Top side. This obviously was a kit. You can kind of tell by the way the leads are routed on this wafer switch. But look at the tubes. They're the old Dynaco made in West Germany, and they're all original. I don't see much signs of any type of past maintenance. The wafer switch looks perfect. Not a lot of corrosion. I don't see any cracked wafers. This thing's in really nice shape. Let's flip her underneath and take a look what's going on down there. Alright, here we are bottom side on the Dynaco PAS preamp. Take a close look at these circuit boards. Normally, when these old Dynacos have had years of wear and tear, you see a lot of heat spots on the board. I don't see any on this one. So it indicates that maybe it did not have a lot of use. Here is the filter cap, and you can see some leakage down there seeping around the terminals. So obviously the main filter cap is bad. Here is the 12x4 rectifier tube, and right here you'll see the outlets that are used to turn on your monoblock amps, right? So these two are unswitched, and these two are switched from the main power little slider switch, okay? And that's why a lot of these switches fail, because they're handling the current of those two external amplifiers. The other thing you'll notice is there's no fuse. Kind of a bad deal. So that needs to be added regardless. Let's go back topside and take a closer look at what's going on there. So here's the power supply section. Main power transformer, 12x4 rectifier tube, the main filter cap, which we already saw the leakage underneath. Now if you swing over here, you'll see a selenium rectifier with two more large filter capacitors. This is for the 12 volt DC circuit that feeds the filaments of all the tubes in the Dynaco to keep her nice and quiet. Obviously all these capacitors need to be changed immediately. I'm going to do that before I even power this thing up. Due to the leakage we already saw, there's no reason to turn this thing on and damage the preamp. Alright, now let's check the main transformer and make sure that's okay before continuing. Before I begin the restoration on this Dynaco PAS preamp, I just want to make sure that the main power transformer is alive. Alright, you just never know what's happened to these things over the past. So I have my meter set up AC volts. I'm looking at the high voltage leads on the 12x4 rectifier tube. I have a variac over here set at about 25 volts, and here is the AC cord, right? I'm just going to plug it in, pull it out, and make sure that we see AC voltage going to that tube. So here we go, plug it in. Yep, there's about 140 volts, unplugged it, so I know that the transformer is alive. So now it's okay to continue with the restoration. Here's a close-up of that filter capacitor. Take a look down there. You can see a lot of ooey gooeys coming out of the leads of that filter cap. Okay, so it is bad. The last thing you want to do is to apply full voltage to this preamp with a filter cap that shows this type of evidence of failure, or you could damage your main power transformer. Alright, so at this point you got to ask yourself the question, do you purchase one of these multi-section filter caps plus these two capacitors, and then obviously you're not going to want to replace the selenium rectifier, you want to take that out. So if you add all that up, it gets very expensive if you want to continue in the stock configuration. But there is an option. Let me show you what that is. So what's the option that D-Lab is recommending rather than replacing those individual caps that I showed you on the chassis? Well, it's right here. This is made by SDS Audio Labs. It is a multi-capacitor circuit board with rectifiers that replace the aluminum multi-section cap and those two 2000 microfarad caps that are on the board and the selenium rectifier. It's all here on the board. And as an added bonus, they included a 3AG style fuse for your AC line, which Dynaco never included in the original manufactured unit.
Yeah.
Oh, great.
Yeah.
It's Dick from the internet. I'm sure he has some constructive input for me.
Yeah.
Yeah. When I rebuilt my Dynaco, I used all original NOS parts. Really? Can I see that on your YouTube channel? Yeah. I'm still editing it. Yeah. Oh, I see.
Yeah.
Yeah, Terry, is that your proper name?
Yes it is.
Oh, not Terrence. Mine is Richard. Dick, for short. Too bad your parents didn't put much thought into yours.
Okay, Dick. This is kind of like a pop-up that I need to close. So let's see if my mouse will do the trick.
Hello, Peter.
To get rid of
What's
this
happening?
pest.
Hello, Peter. What's happening? Okay.
So yeah, if he ever shows back up at D-Lab, that'd be great. So if you buy this little PAS capacitor board from SDS Audio Labs, I'll zoom in, you can see their contact information. You get this nifty instruction sheet, okay? Shows you the circuits board layout, your parts list, and here are step-by-step instructions of how to install it. So first thing you do is you remove this mess, the selenium rectifier's history. You can either remove or leave this filter cap in place if that's important to you. I like to remove it. Then here is the new board, and if you look right there in the center, there's a hole, right? And it mounts where this original stud is that's holding this little assembly. So the board is going to end up somewhere in this area down on the chassis. So let's go ahead and get this stuff removed, get the new board in, wired up, and test her out. Before you get in here and start disconnecting wires and pulling out components, I would highly recommend that you either find your original manual for your PAS preamp, or you can download these for free online. Alright? That way you'll have the original wiring diagrams, schematics, etc. in case you run into issues. The SDS instruction sheet is very thorough, and they're going to tell you what components that you can abandon during this process, because that board has a lot of components that this filter cap and these filter caps utilize to convert the AC to DC in the preamp. So it's pretty straightforward. However, it's always good to have a little insurance policy. Another thing you can do if you're not comfortable is you can get in here and snap some pictures of where the original wiring went. I'm not so concerned about it because I've done a couple of these. You can see here, this is the AC winding coming off the transformer. This is the 12 volt circuit which converts that winding to 12 volt DC. So I'm going to start with this area. And I'm simply going to clip these wires. And I'm going to get this stuff out of my way. I'm going to mount the board. I'm going to remove the other filter cap and rewire this thing. Alright, all the wires are clippity-doo-dah off of there. And there goes this mess. It's out of my way. Next, let's get this guy out. Same deal, here's the main filter cap. We're pretty much going to clip all the wires. We're going to abandon the filter cap and the resistors that you see here going to the multi-sections, alright? Because the new SDS board has those resistors and has the 4 caps that represent that. So you're pretty much going to get in here, you're going to cut these wires off, cut them close to the filter cap, because you're going to get in here and these leads will now swing to the top of the board and go to the new SDS circuit board. All the leads now are disconnected from that old original filter cap. Now you can just take a pair of pliers, these little twisty tabs here, just turn them, break them off. Alright, they'll come off. And after you take all those off, that filter cap will drop right out. So there are the 4 little lugs that were twisted underneath the chassis holding the cap in place. So now he'll pop right off. If you take a close look there, you can see all that old leakage coming out of the cap. This guy was shot. So the original values here, 30 microfarad, 20, 20, 10, all at 450 volts. And you can see right there, it's got the old Dynaco emblem with the part number. Very cool. In the SDS instruction sheet, they talk about the ground wires that originally went to the lugs on the old filter cap, and they say if you leave the filter cap in, do not disconnect those grounds. Well, if you take a look at how the filter cap was installed, it had pretty bad grounds to begin with. So obviously, since I removed this cap, I lost those grounds. So I install a ground lug and I bring over the wires that were originally providing the grounds to the 2 circuit boards. If you look at your schematic, you'll see it's terminals 4, 11, and 1 on this board. So you want to land yourself a little ground lug like I have here, okay? And just solder those 3 wires back to that ground. And then if you say, well, you know, that is still a mechanical ground connection, you could come in with old Ungaramus, the old Gigantico soldering iron, put it on that chassis, and give yourself a nice bonded solder connection to the chassis, which would be better than original. So our ground connections are complete. These are the 3 grounds here that fed the circuit boards, and this red and yellow wire, which goes to the power transformer center tap, is also connected to this lug. The next step is to take these 3 wires and bring them topside and hook to our new SDS capacitor board. So as I showed you earlier, topside, this hole here was for the mounting stud that went up and held the original capacitor and selenium rectifier assembly. So our new board is going to be sitting in this area, right? So if you take a look off of the rectifier tube, you've got about 1-inch wire. You got this little guy, it's about 3 inches coming off of terminal 16. And then you have this wire that goes all the way over here to terminal 16 of the other circuits board. That wire is probably plenty long enough to go through this hole and mate up with a new board, but these 2 are not. So you're going to have to extend these 2 wires to be able to get up topside and hook up to the new SDS capacitor board. Here's the extended wires I decided to color code these to make it a little bit easier. So I used the red that comes off the rectifier tube. This white comes off of 16, which goes to this first circuit board, and then of course the black is the original wire that went to the other board. So that'll kind of help me to keep things organized when I hook up the new board on top. Well, here is that original long mounting stud that used to hold this capacitor and selenium rectifier assembly. Your new board is going to go down on that stud in this configuration. You're going to see these little green caps over here. Those are the 2200 microfarad caps. So this guy is going to sit about here. Alright, now there is a nut that you're going to adjust to get proper spacing on the board. Okay, you don't really want it floating up here in outer space, but you also don't want to have the caps hitting the chassis and then put your other nut on here and damage the caps. So you have to kind of adjust that spacing. These leads here are from the original power transformer. They have to land right here and here. You'll see that in the instruction sheet. So that's why the board has to sit in this orientation. Alright, so let's get it mounted and then we'll start landing the wires on the pads on the old circus board. So here's our mounting stud. I have a nut there and a washer to get the spacing for the board to sit in place. Okay, now you can see these two caps. They're going to be sitting on the chassis. So to kind of buffer that a little bit, I put a piece of felt here so that the board can sit. Hold the stud and make sure that it's sitting on that stud and washer. Okay, so the pad's just there to kind of give the caps a little saddle area. And put another washer, lock washer, and the new nut. Get that tightened up and then we'll get things wired up. So I've got the board mounted securely and now I'm ready to start wiring this thing up, and this is where you really have got to take your time and pay attention to what you're doing, because if you get wires in the wrong place you're going to damage your preamp. Alright, and you sure don't want to take out this power transformer. So take it slow, one at a time, and you'll have success. Okay, so I'm going to keep wiring this up one step at a time. So one of the first steps in the SDS instructions is to hook up the AC line cord through the new fuse that's on the circuit board. Well, I'm going to do that last because I would rather get this thing wired, make sure it powers up, and then I can always bring the AC line cord through that fuse later. So at this point I have the 12 volt filament line hooked up here to the diodes and the filter caps. And next we'll go through the rest of these wires, get them all connected up, then I'll bring this thing up slowly on a variac, make sure I didn't make any boo-boos, and we'll see if all the power supplies come to life. At this point I have the filament circuit connected. Alright, so this is the main power transformer. These two blue leads is the 12 volt AC filaments that goes to the 12X4 rectifier, which is these two black leads. Then you've got two pairs of wires that come up from under the board and they're poking through. These feed the DC filament circuit to the 12AX7s on PC5 and PC6. So all four of those leads are connected. Now to verify that you have that right, take your ohm meter, go across those two lines, and you should see approximately 13 ohms. If you see 0 ohms or say 26 ohms, you've probably wired it wrong. So double check your wiring, but 13 ohms is the target. So next we're going to hook up the high voltage leads. And remember, I extended these. The red and the white were my extended wires, the black was the original. So we're going to hook up the high voltage section now to to the 4 high voltage caps that represented the 4 section aluminum electrolytic that was originally in here. So the board wiring is complete, so let's review what we did. These blue wires right here are the 12 volt AC filament lines coming off of the power transformer. Those feed the 12X4 rectifier tube directly, okay? That's the 2 black wires. Then they're rectified and you've got 4 wires, 2 pair here and 2 pair over here, which is the 12 volt DC circuit that feeds the 12AX7 tubes on the 2 preamp boards. That's why these things are so quiet. This red wire is coming off of the high voltage output of the 12X4 tube, and that goes through the first filter cap. Then you got this white wire and this black wire, which goes to pin 16 on the PC5 and PC6 circuit boards. So these are the high voltage leads that feed those preamp boards, okay? Then you never want to forget to run yourself a separate ground runner from this pad, which is the common ground for all the filter caps, direct to chassis ground. Do not rely on this mounting screw to give you a mechanical ground connection. Solder that direct. Save yourself some problems. Now it's time to fire it up. Now we already buzzed out the filament circuits on the DC side had our 13 ohms, so we know that's wired correctly. But obviously before we apply power, it's always a good idea, take your ohm meter, check it first, make sure it's working. Let's go to ground, and let's go to the B plus input, which is right there. And let's go to the 2 B plus outputs that feed PC5 and PC6. Make sure that you don't have any shorts. And then of course this one we want to be shorted to ground because that is our ground connection. So everything looks good. I'm still going to bring it up with a variac and measure the voltages, make sure everything looks cool, and then we'll give this thing a test. Initial test of the Dynaco PAS after replacement of the capacitor board. My meter set up for DC. We're looking at the first filter section coming off of the 12X4 rectifier tube. Got it on a variac over here. I'm going to bring her up slow. I'm watching my current. Minimal current looks good. Around 50 volts input right now. You can see we have nothing on the meter yet because we got to warm up that rectifier tube. But I do see the idiot light down there lighting up. It's a good sign. It means we have filament voltage. And look, the meter, we're starting to get some voltage building up. I'm at about 80 volts input. You see our high voltage coming up. Looking good. Bring her up to about 100 volts. See, we've got a little over 300 volts there, plate. No fire shooting out of it. Appears as though all the tube filaments are lighting up. That's a very good sign. So next, I'm going to bring her up full voltage. We're going to check our other voltages, make sure everything's cool, and then I'll try to put a signal through it. For the initial signal test, I have a WaveTech audio generator. We're going into the special input on the left channel only, just to see if this thing will pass a signal. I have not cleaned the switches, the pots, anything. I've only repaired the power supply. So here we go. See our signal over there. Jumping around as I would expect because the controls are dirty. But sine wave looks good. I would expect that fluctuation. So all in all, that's a really good sign that this PAS is going to come right to life after a good cleaning. Possibly check the connections on the tubes, because you can see things are kind of flipping out a little bit. But all in all, I'm very happy with this Dynaco PAS. I think it's going to be a great unit. Alright, mission complete. The new upgraded capacitor board is installed in the Dynaco PAS. And you can see it's really not too bad of a job. Just got to take your time, make sure you get all those connections in the right place, and also make sure you get a good ground, and that thing's going to take off running again. Probably save yourself a lot of money over trying to replace those original components. Alright, now I looked up the price on the current SDS Lab boards that are sold by Triode Electronics. They get about $63 for the full kit. Okay, you can also just buy the circuit board itself if you want to stuff it with your own parts. And if you do a little looking around, like on eBay, you may even be able to find it cheaper. But this is a great alternative to trying to track down those original parts, and it's much easier to install. D-Lab recommends it. I hope this video is good for you. If you have a PAS in need of repair and you don't want to do it yourself, get a hold of me. We'll see you.
Yeah.
Yeah, well, if you can't get a hold of D-Lab, you can get a hold of me, Dick, from the internet. Now do it right. That'd be great.
Yeah.